One of the most captivating cosmic phenomena is the possible supernova of Betelgeuse. Situated in the well-known shoulder of the star grouping Orion, Betelgeuse is a crimson supergiant nearing the conclusion of its life cycle. Unexpectedly in 2019, one of the most luminous stars in the heavens began to dim noticeably, being discernible even to the unaided eye. But for several months, its radiance diminished to such an extent that numerous watchers speculated whether the star was perishing. Betelgeuse is thought to be on the verge of erupting into a supernova, signaling the conclusion of its stellar life. However, when and why will this cosmic detonation transpire? Could it pose catastrophic impacts for our planet? The radiant scarlet star Betelgeuse is located on the upper right shoulder of Orion, the Hunter. You might recognize it by its alternate name, Alpha Orionis. Even though it is the second most luminous star in that constellation, following the brilliant supergiant Riel, it continues to intrigue scientists due to its fluctuating behavior and distinctive moniker. Alpha stars are commonly the brightest within their constellations. And even though Riel surpasses it in brightness, Betelgeuse attracts attention because of its substantial size and reddish hue. Betelgeuse, also called Alpha Orionis, ranks among the most renowned stars in the night sky, being the 10th most brilliant and 7th most visible for much of North America, Europe, and Canada. Its designation is derived from Arabic and indicates the armpit of the giant. Referencing its spot in the constellation, Betelgeuse sheds about one solar mass every 10,000 years, releasing materials uniformly in all directions and generating a nebula surrounding it. This nebula spans 30 astronomical units or 30 times the distance between Earth and the Sun and is 250 times more massive than the star itself. At its heart, Betelgeuse hydrogen nuclei merge under gigantic gravitational pressure, creating helium and emitting radiation and heat in the process. As the star depletes its hydrogen, it begins fusing helium and carbon as substitutes. When helium runs out, neon combines with carbon to yield iron. The merging of iron fails to produce energy, leading the star to collapse under its own gravity and ultimately burst into a supernova, one of the universe's most forceful explosions depending on age and developmental phase. Stars emit illumination in various wavelengths, from the bright blue of young stars to the red of older ones. Based on the historical stargazer Tommy, Betelgeuse exhibited a hue he intriguingly labeled as ruddy. However, early Chinese astronomers remarked that Betelgeuse appeared yellow, hinting that it may once have been a yellow supergiant. Massive stars rapidly burn through their hydrogen, leading to an early demise. Although their lifespans last only 10 million years, there is no doubt that Betelgeuse is in its concluding phase. While our Sun still possesses more than 5 billion years of life, Betelgeuse is approaching its final moments, meaning it may soon erupt in a supernova. However, the precise schedule of this occurrence remains elusive. Betelgeuse experiences cycles of brightening and fading, one occurring every 5 years and persisting for around 100 days. It's assumed that the swelling and shrinking of its outer layers during these rhythms trigger changes in its diameter and overall surface temperature. Great interest in Betelgeuse grew during its unpredictable behavior in 2019 and 2020 when its light diminished dramatically before recovering briefly. Certain scientists have theorized that this abnormal activity could indicate the star is nearing its final transformation. Full analysis of Betelgeuse dates back to the 1st century BC. Yet, the origin of its dimming remains an absolute enigma. Betelgeuse has been spotted moving through the interstellar environment at about 30 km per second after being thrown from its birthplace within the Orion-Obi-Wan group, which houses the stars of Orion's belt. The resulting bow shock extends beyond 4 light-years. Measuring the proximity of red supergiant stars like Betelgeuse is an infamously difficult task in astrophysics as various factors prevent accurate diameter estimates. Furthermore, because it is a pulsating star, Betelgeuse's size varies over time. This characteristic along with the dimming of its periphery causes its observed glow to shift in shade and diminish as we view it further from its core. Additionally, the shell of material expelled by the star plays a critical role in light emission and absorption, also affecting how we interpret its brilliance. Directly contrasting views of Betelgeuse is challenging since its visible size changes with the wavelength observed. These measurements can vary by as much as 35% based on the part of the light spectrum employed. In July 2009, the European Southern Observatory released visuals captured with a Very Large Telescope (VLT) interferometer at its ground-based observatory, revealing a massive plume of gas stretching up to 30 astronomical units from the star's surface. One of many mass expulsions visible from Betelgeuse. This outflow matched the angular distance between the Sun and Neptune. At least 6 such events were observed around Betelgeuse. These occurrences may reveal clues to the question steward of mass ejection in the concluding periods of massive stars which are relevant to their destruction. The complex processes within Betelgeuse's extended outer layers remain puzzling, as does the exact mechanism by which red supergiant stars shed their matter. Such stars are essential to the flow of elements within galaxies, and due to progress in interferometry, astronomers are approaching answers to these riddles. In 2019, scientists employing the Hubble Space Telescope and other observatories discovered that Betelgeuse had blown off a tremendous portion of its outer shell, triggering a massive surface mass ejection, SMME. Although the Sun creates solar mass ejections, Betelgeuse's events were thousands of times more intense, with this event flinging out material 400 billion times the mass of a regular solar eruption. This accounts for why Betelgeuse suffered a steep drop in luminosity from October 2019 through mid-February 2020, when it had lost nearly 3 times its brightness, moving from magnitude 0.5 to at least 1.7 by February 17, 2020. Betelgeuse's brightness had stayed largely consistent for more than a week. On the 5th, it appeared that the dimming had stopped entirely, but the latest reductions in visible light were not connected to a possible core collapse, as no significant changes in infrared radiation had been registered on February 24, 2020. Feel free to share your thoughts in the comments section. If you enjoyed this video, click the thumbs up icon and subscribe so you won't miss future content like this. When Betelgeuse eventually detonates as a supernova, it will be among the most dramatic cosmic occurrences ever documented, even at a distance of 640 light-years. The blast will be so radiant that it may outshine the entire moon and even be visible during daylight hours for several weeks or even months. Experts estimate that the supernova will discharge more energy in mere seconds than our Sun will emit during its entire 10 billion-year lifespan. The illumination from the explosion will speed through space and eventually reach Earth as a stunning pinpoint of light unlike anything we've witnessed before. Rest assured, we are completely safe. Although a supernova that close may sound threatening, Betelgeuse remains distant enough that the detonation will not harm Earth's biosphere or living beings. What it will do is present an exceptional scientific event. As of the past few years, Betelgeuse has returned to typical brightness levels. But its irregular dimming patterns are still under intense observation. Scientists are leveraging tools like the James Webb Space Telescope, the Hubble Space Telescope, and land-based interferometers such as the VT and ALMA. They're monitoring surface light fluctuations, patterns in convective activity, and persistent mass outflows that appear to reflect the star's instability. One well-supported theory is that Betelgeuse's significant fading was triggered by a sizable cloud of starborn dust created during one such eruption, momentarily veiling the star's light from our standpoint. Grasping the mechanisms behind Betelgeuse could help astronomers decode the life stages of colossal stars, particularly those nearing a supernova. Such insights could assist in forecasting similar phenomena in other galaxies, explain how chemical elements enrich the cosmos, and detail the formation and scattering of elements like iron and gold throughout space. Betelgeuse is effectively a ticking cosmic timepiece, and it is winding down slowly. It may explode tomorrow, next year, or in 100,000 years. However, whenever it does, it will present a galactic spectacle and a wealth of scientific data unrivaled in modern times. Understanding the life and death of stars like Betelgeuse is not only a matter of academic curiosity, it plays a critical role in shaping our comprehension of the universe itself. Massive stars are the forges where heavy elements are created. When these stars reach the end of their life cycles and explode in supernova, they scatter these elements into space, enriching surrounding interstellar clouds with the building blocks for new stars, planets, and even life. Betelgeuse's approaching supernova offers an extraordinary opportunity to study such an event in relatively close proximity. Most supernovae observed by modern science occur in distant galaxies, limiting the detail and information scientists can gather. However, with Betelgeuse in our own Milky Way galaxy and relatively nearby in astronomical terms, astronomers could reveal every stage of the explosion and its aftermath with unprecedented clarity. This potential observation is particularly exciting for those studying neutrinos and gravitational waves. When a star collapses into a supernova, it doesn't just release visible light. It emits vast quantities of neutrinos and may produce detectable ripples in spacetime. If Betelgeuse were to go supernova, detectors such as LIGO, Virgo, and IceCube could capture this data, providing new insight into both stellar physics and the fundamental forces of the universe. Moreover, astronomers are paying close attention to Betelgeuse not just because of its possible demise, but because of what it can teach us about stellar behavior in general. Red supergiant stars like Betelgeuse remain among the least understood stages in stellar evolution. They are massive, unstable, and difficult to model accurately. Advances in space telescopes and high-resolution spectroscopy are helping to change that. But many questions remain, unanswered questions that Betelgeuse might soon help resolve. In the meantime, Betelgeuse continues to flicker, pulse, and intrigue us. Its brightness may seem consistent for now, but scientists remain on alert, ready to capture every fluctuation. In the event of a supernova, the data gathered could revolutionize our understanding of how stars live and die. Till that moment arrives, be it tomorrow or millennia from now, Betelgeuse will remain a focal point in the night sky and in the imagination of astronomers everywhere. It stands as both a celestial marvel and a cosmic countdown.